Okay, we are on Unit 5, Day 2, and we're doing reflections today, which are flips. And each time they're going to have a line of reflection, just like we talked about the line of symmetry. This is a line of reflection, and you'll notice again, just like last time, my original pre-image is my first one, my image is my second one. And on my image, they have the prime with them, just like we talked about with the translations. And you may notice that when I look at these points, these two go together, x and x prime, they come through here, and this side of the line is the same length as this side. And this is my line of reflection. And it cuts this line into two equal parts. Those two parts are congruent. And this line that connects these points is perpendicular to my line of reflection. So this is actually a perpendicular bisector of this line here. And I could find the midpoint of this line in between here, and it would be on this line. So kind of a little bit of stuff about these. And it works with every one of them. If I connect the W and W prime, this side is equal to that side, and it's still perpendicular to my line of reflection. So on here, just like we said before, this is our second kind of rigid transformations. And most of the stuff is preserved. And I'm using the word preserved because that's the wording that they're using on the test. Preserved means they're just not changing, and not preserved means that it might change. So the length of xy, does the length of xy change from here to there? Those look the same, so that's preserved. Parallelism, so that means parallel. xy is parallel to wz. Are they still parallel here? Yes, they are. Angle y, is this angle still the same as angle y prime? Yes. How about the slope of xw? xw here versus xw there. Oh, look, the slope changed on those. That's not preserved. The length of yw, that's the length of the diagonal. Does that stay the same on both of those? Yep, those are the same size. The perimeter of this one is going to be the same as the perimeter of that one. And how about the area of this one versus the area of that one? That's going to stay the same. So literally the only thing that's changed here is the slopes might change because I actually flipped it. I might have a positive slope here and a negative slope there. Other than that, these stay exactly the same. Now we are going to talk about a little bit of algebra here today because we have to talk about where this line of reflection shows up. So we're going to talk about some special lines. And we saw these a couple of units ago. Horizontal lines might be this one, or it might be like this line, or it might be this line right here. Those are all horizontal lines. Let's talk for just a minute about what the equations of these lines are. Well, this is telling me where it's crossing the y-axis. So this one is at y equals 3, y equals -4, and this one would be at y equals 0. This one also happens to be the x-axis. So I might call, if the line of reflection like this one right here, on the first one we did up there at the top, that would be a line of reflection on the x-axis or over the line y equals 0. The same thing we can do in the vertical. I could reflect across the y-axis, and this would be the line x equals 0. Or I could go over some other line like this one, would be x equals -3, or I could do this one here, this would be x equals 2. So if it's a y equals line, it goes this way. If it's an x equals line, it goes this way. Do notice though that y equals 0 is the x-axis and x equals 0 is the y-axis. That often confuses people. That's just something you have to remember. We're also going to see ones that go right on the diagonals. And these lines sometimes confuse people as well. This point right here is y equals x. And this line is y equals x because if we think about y equals mx plus b, what's the slope of this line? Well, it's rise 1, run 1, so it's a slope of 1. And where is it crossing the y-axis? Well, it's crossing at 0. So if it's 1x plus 0, that's just x. So this line is y equals x. And likewise, I could do the other one. This one here is the same thing, it's just got a downhill negative slope, so this is y equals negative x. So these are the lines you need to remember, and these are what all of our lines of reflection are going to be. Alright, so now let's talk about actually taking an image of 2, 3, here's A, and let's do each one of these things it says. It says first, let's reflect across the x-axis. So we're going to reflect across the x-axis, which is also the line y equals 0, just like we had here. And if I reflect it across this line, it's going to be right here. There's going to be A prime. And I'm going to call this one A prime. And what rule do we see here? Well, this was at 2, 3. Where's this point going to be at? Well, it's going to be at 2, negative 3. So when I do that, what happened to my things? Did the x change? It didn't change, so it's just x, and the y stayed the same, it just became a negative. So that's our rule for that one. So on the next one, now we're going to go back to our original, and I'm going to go across the y-axis, that's the line x equals 0. Let's call this a double prime. So I'm going to go to my original, go across the y-axis, that's going to put it right here, a double prime, and that point is at negative 2, 3. So let's write the rule for that one. Did the x change? This time the x became negative and the y value didn't change. So there's our rule for that one. Now let's go across the line y equals x. That's this line right here. So it's going to be, I can draw a little perpendicular line. I know it's the same distance away on this side, so it's going to be right here. So where's that point? Let's call this a triple prime. And that's going to be at the point 3, 2. So let's compare it to our original. What happened to the rule here? Well, what happened was the x and y changed. So my rule is, it's going to be yx. I basically took these numbers and I changed the places. Okay, so now we're going to see a couple of things that they're talking about. We're going to connect perpendicular bisectors and midpoints. We know midpoints cut a line into 2 equal parts. And a perpendicular bisector is exactly what it sounds like. Perpendicular means they're going to cross at 90 degrees. Remember, that's our sign for perpendicular. And a bisector cuts something into 2 equal parts. So we're talking about a line that cuts another line into 2 equal parts. So here it says, give the equation of the line of reflection and give the midpoint of the segment. So where is this line? This is my line of reflection. What is the equation of this line here? We just talked about on the other side, if it's a horizontal line, that's a y equals, and it's at y equals 4. And let's give the midpoint of this segment. It goes from S to S prime. Where is that midpoint going to be right there? Well, that midpoint is going to be at 3, 4. All right, let's do the same thing on the next one. Here's my line of reflection. It's a vertical line, so that's an x equals line. And it says the midpoint of S to S prime, so it's right there, right exactly in the middle. Notice this is the same size on each side. And so that's at 5, 3. And finally, this one, let's do the line of reflection. Now, this is not exactly one that we had before. This one we're going to have to actually figure out the whole line using y equals mx plus b, because it's not exactly one we put on the other page. It's not a special line, this is just a regular line. Well, m is my slope. What's my slope here? Well, it's down 1 over 1, so that's negative 1x plus, and b tells me where it crosses the y-axis. Well, it crosses at 7. So here's my equation. Negative 1x is just negative x, so we could just write y equals negative x plus 7. And then where's the midpoint of this line right here, between s and s prime? Well, it's halfway, so how do I write that? Well, if it's halfway between 3 and 4, that's at 3.5. And it's halfway here, that's between 3 and 4, that's also at 3.5 is our midpoint. Alright, and then we're going to talk about composite transformations. Composite transformations is when I have more than one thing happening. So let's just describe it in words what happens. We're going to go from A to A prime to A double prime. So from A to A prime, I have a translation. Down and then over. So this is down 5 and right 2. So that's down 5, right 2. And then what happens from here to here? Well, that's a reflection across what? Across the y-axis or the line x equals 0. Now let's do this one. From A to A prime, okay, well that's a reflection across the y-axis or the line x equals 0. And then we have a translation here, so from here to here, we have down 5, right 3. So this one is not anywhere close to this one. Does the order that I do the two different transformations matter? If I slide, then reflect, is it the same thing as reflect and then slide? Those are not even close to the same, so the order matters when I'm doing them. I have to do them in the same order that the question asks. So now in these last two, you do these, pause the video, and then come back and check your answers. Okay, you should have paused the video and then come back to check your answers. This one first, it goes from here to from A to A prime. That's a reflection over the line y equals 0 or the x-axis. And then there's a slide to the left 5 from A to A prime to A double prime. And then on this last one, it's first a slide up 5 over 1 from 1 to 2. And then it's a reflection across this line, and this is the line y equals x.